Okay, we'll get started. For those in the back, there's plenty of seats still to sit down, so you don't have to stand up. And we'll get this started. This is going to be one of the best sessions you're going to see at the summit. So I've got Justin and Fabian here, and they're going to give you like a sample platter of ways to optimize the Databricks platform. So give them a round of applause, and let's get it going.
Hello. All right, hello. Everyone can hear me. Sweet.
Hello.
All right, I'm Justin. I've got a lightsaber of a pointer, so that's pretty cool. So yeah, best practices for running efficient Apache Spark workloads on Databricks. I'm Justin, staff PM. Fabian, we'll get you introed in a second.
Yeah.
We're going to talk about some preview things on here. So safe harbor slide, you've probably seen it before, but I'll let you digest it for a couple seconds before, we just click through it. Okay, so I'm Justin, 4+ years at Databricks on the product team. I focus a lot on the runtime itself, Photon and Spark, and kind of all the goodness that surrounds that. I live in Topanga, so in the LA area, up in the mountains, and that's me and my little buddy. Who are you?
I'm Fabian. I'm a senior staff engineer on the developer ecosystem team. It's a new team that we created for external developer tooling, things like CLI, SDK, Terraform, infrastructure as code, CI/CD, and IDE. And I've been working in the developer tools space for like 10+ years.
Very cool. Nice to meet you.
Yeah, nice to meet you, Justin.
Yeah. All right. So, gonna kind of jump into this. Guess it makes sense to start. So, if you were to ship like a data product or a use case, by the time that you're done, it's going to comprise of a lot of different things: ETL code, data warehousing code, dashboards, alerts, maybe into the ML space. You got LLMs, model training code, all sorts of fun things. So you're going to create a bunch of assets. You're going to leverage a lot of tools. Fabian just mentioned a lot of acronyms, but IDEs, Git, CLI, APIs, all sorts of love language things. Yeah, notebooks. You might even have an orchestrator. I hope you do. And then data sharing, compute, and then, yeah, you need this catalog to kind of govern it all. That's super helpful. You're going to have a lot of concerns along the way. Yeah, hopefully people are like, oh, yeah, shit, we should be thinking about these. Oh, I guess I'm not supposed to swear. Anyway, cost controls, data quality, developer productivity, but then also you want architectural flexibility, and yes, this governance thing, it keeps coming up. So it's like, wow. Now you might ask, like, what does this have to do with Apache Spark? Well, you can do a lot of these with Spark, and what Fabian's going to talk about is how do we use the tooling to make your life easier. And then Databricks is a platform, we help alleviate these concerns along the way. So that's kind of how we're logically grouping these things together. And traditionally, people are stitching together a lot of platforms trying to make this happen. There's a data lake, data warehouse, orchestration. Again, our good friend governance is there as well. And you're trying to stitch these things together, and generally it's just unnecessarily expensive and complex. Like the way I like to think about it is every engineering team has a finite amount of calories. Where do you want to spend them? Do you want to spend them trying to glue a bunch of things together, or do you want to spend those calories trying to push the business forward and giving them awesome capabilities? So now, like, talking to customers over the many, many years and trying to distill into a simple statement, like what do people actually care about? Executives, they want to enable the team to ship data products faster. The architect, they would love, right now they've got a lot of architects or a lot of architectures. Some are kind of one-trick ponies, but they would love to get down to like a single architecture. They would want to stop duplicating data. The developer, basically wants to actually write code instead of fighting operational fires, and they also want to hang out at Data and AI Summit, hopefully. That's why you're here. And then analysts would love some fresh data and a faster time to value. So we're going to kind of think about these things in different sections throughout the rest of the talk about making these efficient workloads across the entire platform. And in these three kind of segments: flexible architecture, developer productivity, and then fresh data and a fast time to value. And if you do these things right, you do these three things right, That'll enable you to ship data products faster, have higher quality, cheaper, live forever, all the fun things. So we're going to talk about some things about whole flexible architecture. Little bit on the lakehouse. If we got a level set here for some people, you never know. So basically, starting with the raw data on the lake, having a single platform to manage all the structured, semi-structured, and unstructured data. Super key, though, having one security and governance model. I'm sure you've heard the term UC or Uni catalog. If not, you're going to hear it a lot more. Hopefully, you don't drink every time you hear the term Uni catalog, because if so, you're going to have a great time. And then one platform to support multiple personas. And this is a super, super key thing to help alleviate you from trying to stitch multiple things together. So basically, have the capabilities to do BI, data warehousing, data engineering, streaming, and then DS and ML, AI, oh my. All right, and then Databricks, I mean, we basically, how we do that is, we basically do this in a single platform. There's Databricks SQL, there's Databricks Workflows in terms of orchestration, DLT, one of my personal faves, and Databricks ML. And of course, having governance under UC and bringing Delta Lake to the party too, because that's always a good time. And so that's the idea is Databricks is delivering this unified lakehouse to help you ship these data products faster. So if we keep double clicking a little bit, UC, for those of you not in the know, of course, like I said, sampler platter, we're going to spend some time on a bunch of different things. UC is a way of doing access controls, data discovery, lineage, monitoring, auditing, data sharing, all these things. And effectively, it's also capturing the metadata. So like where do these tables live? What are all these files? Serving that information in a super, super fast and performant way so we can have faster queries. Then you also have, and kind of the cool thing would be top right, so like external compute platforms. Ooh, and I think we can do this laser pointer too, that's sweet. All right, so external compute platforms, we can bring those into via an open interface, which is awesome. So exposing UC is just a generic HMS, so it's cool. Then you have, of course, raw files on the lake, catalog federation to kind of bridge the gap to where you are today. A lot of people have metastores. It's not necessarily a new thing. But if you want to bring that data into UC to start to get value out of it, you can do that too. So UC, unified governance for data analytics and AI. One of my personal favorites, though, lineage. It's awesome. So basically, where does this table come from? And lineage is not just within UC, but within workflows as well. So think of your workflow, you have a DAG, and when you're trying to troubleshoot, you can kind of see, well, basically it happened in this upstream spot, and then workflows can start to give you insights to where and why this job fell down. And within UC, you also have lineage as well. Where do columns come from? Basically the column lineage. So if I'm using the same column in many, many different places, getting some insight into that. Same thing, like where is this table being used? So super powerful, awesome for root cause analysis, and to someone like me with kind of a spacey brain, it's awesome to keep me focused. Delta Live tables, and you might be wondering, what does this have to do with flexible architecture? Great question, glad you asked. So basically, do you want a single place where you can do batch, streaming, built-in testing, built-in data quality, and no upgrades necessary? If so, DLT is for you. It's really, really awesome. Been working on it 3+ years. And to me, the cool thing is you don't have to worry about kind of implicit orchestration. Basically, traditionally, you're going to have to go through with a workflow, whether you're using a Databricks workflow or you're using Airflow, and you're going to have to create the order at which these different jobs run. However, with DLT, you don't actually have to do that. DLT is super smart, and we wanted to see how smart it was. So basically, we built like this kind of complex TPC-DI benchmark, and then we manually put together a workflow of what we thought would be the most optimal. Then we built the same code, but as Delta Live tables, and just said go. And when we did that, DLT was able to improve, it was basically cut the time in half and cut the cost in half. So if you think humans are great at doing orchestration, unfortunately, the data is starting to look like we're not. So if you can use something like DLT, it's going to make your life a lot easier, and you don't have to think about this. That's the really, really cool part. All right, making developers more efficient. We're now into the second phase of this talk. To me, or a key thing of Databricks, especially in the R&D org, company-wide, you could even say, is meeting the developers where they are. Some people love these things called notebooks, and notebooks are great. In Databricks, we've had pretty cool notebooks for years. We're constantly investing into them. Other developers love IDEs, APIs, and that's what Fabian speaks, and that's great. So I'm going to spend a minute or two talking about what we're doing to make your guys' lives easier in notebooks, and then I'll hand it over to Fabian. Unified search, this is awesome to navigate and discover content throughout the Lakehouse. I used this actually a week or two ago. I had a bunch of different tables internally. I was migrating a bunch of my internal jobs over to Unity, and I was trying to figure out, well, where are these tables used? Traditionally, that simple question was super hard to answer, but actually now I just was able to put in my table name, and I could see every single query that it was referenced in within Databricks SQL. I could see every single notebook that it was in. So it allowed me just really quickly just to go through whack-a-mole, make the changes necessary. Without this, it would have been a lot more complicated and complex. So a simple, delightful feature, unified search, it will make your life a lot easier. And programming ergonomics, another delightful feature. Or a delightful section. So Python formatter, we've invested a ton into that basically if you want to just run selected text, things that you can do in the SQL side and have been able to do for a long time, you can now do that just in Python. Like, mind blown, whoa, I know. Go to definition, go to error, auto-import libraries. But my favorite is this screenshot that's on the right-hand side. It's like a variable explorer. Like, what variables have I put into the REPL? Super, super helpful, so I can see what's there, kind of what it was made up with, where did I do it. Very, very, very helpful. And IDEs, my esteemed colleague, Fabian.
IDEs. I'm not sure if you all went to the keynote this morning. Everybody has their own favorites. My favorite was in the first 10 minutes when Satya Nadella said how cool the Databricks extension for VS Code is. That made my day. I was ready to go home. Because no, that he didn't say. And I want to show you why I think he's right. I think he's right with this. And Justin mentioned lots of folks who love their notebooks. I like notebooks too, but I'm an IDE guy, so I prefer to spend my time in IDEs. And why? So over the years, one of the most requested features for Databricks was, I want to develop in my IDE. And as I mentioned, some of our customers use exclusively IDEs, and they basically told us, we want better support. You need to help us. They want to use, integrate their tools. They want to use Git. They want to use command line tools. They want to use IDEs. And to be honest, we made it really hard for them. They were DB Connect version 1, which was notoriously hard to use, not very well maintained by us. There were a bunch of other extensions, and but it was really hard. Was not really present to use. And that's why we set out, about a year ago, we started creating the Databricks extension of VS Code. You see a screenshot here. You can download it from the marketplace. And basically, it allows you to develop natively inside of VS Code. You can use all of the language features that VS Code has for Python, like go to definition, refactoring, test runner, you name it. So you leverage all of the capabilities of the IDE. It's very, very simple to set up. But instead of just telling you, I just want to show you. Oh, wait a second. Before I do this, we actually launched this as a GA product last week, just before Data and AI Summit, before I boarded the plane from Amsterdam to San Francisco, hit the button. It is available as a GA product now. 1.0, yes. So let me just show you how this looks like. Is that big enough? I'll make it a little bit bigger. This is bigger. And basically what I have is like I have a very simple Spark job right now. This is a pure Python job that I have here in my IDE. I use pandas, I use PySpark, nothing special. And I can just use like go to definition, I can use code completion, everything that you love and know from an IDE. And on the left-hand side, there's a Databricks panel. And basically what this allows you to select a workspace, the workspace that you want to run your code on. You can authenticate using a personal access token, but we also support other methods like Azure CLI. Then you need to select a cluster. And I hope this cluster is actually running. So you need to select a cluster where you can run your code on. And then what we do is like when you run this code, we synchronize the code to a Databricks workspace, and then we run it remotely. Let me just show you how that looks like. So here we have upload and run file on Databricks. I can click this. No, it's not running. Oh, there's another one. OK, I have a better one. Live demo. This is live. This is live. There's nothing recorded here. So what's happening now, it's like it's first, you see this here, it's now starting the synchronization process, and the synchronization actually happens in the background. When you edit a file, save it, it will detect it and upload it again. And then it will basically create an execution context on the Databricks cluster and run the code. And you see the output here live in the panel. It's actually very, very simple. It just synchronize the code, run it remotely, done. So that was the IDE. One thing you might have noticed is like I mentioned that we run on the cluster, and there's one feature in the IDE that actually doesn't work. And that is a feature that everybody wants to have, that is step debugging. Since Python is running not on my laptop, but on the cluster, VS Code has no idea how to connect to that. But luckily, we got you covered here too. A couple of weeks ago, we GA'd DB Connect version 2, which actually does allow to run code on your laptop and then do debugging. You might have heard about Databricks Connect. Basically, what Databricks Connect is, it's creating a data frame API that any application outside of Databricks can use to talk to a cluster. So this can be a data application with Plotly that is hosted on a normal web page. It can be partner integrations. But what matters for me is it can also be an IDE. So I can run my code using Databricks Connect. I run my Python locally on my laptop. I can attach the debug to this. And when it talks to the cluster, it will basically serialize the data frame operations, run it on the cluster, get the results back. So that is kind of the missing piece. And I encourage you to check out Spark Connect and Databricks Connect. So now we have our code on our laptop. Maybe we put it in a Git repository. Now what? Right? So the question is like, how do I get the code that I develop into a stable production environment? And one very exciting project that my team has been working on is called Databricks Asset Bundles, which allows you to model Databricks assets like jobs and notebooks in code. So basically, anything that you can create in the web UI as a resource, like a notebook, DLTs, jobs, dashboards, you will be able to kind of model in a very Databricks-specific way in a YAML file together with your code. And then you then can use a CLI to say, create all of these resources, upload the code of these resources, and run stuff for me. And this is great like for local development, but it's even better for continuous integration. So you can run this as part of like a GitHub approval workflow, Azure DevOps workflows, and you can like fully automate the journey from development to testing to production. Here's an example. So this is how the YAML looks like. Basically, you give it a name, You tell it which workspace to use, which Databricks workspace. You create a bunch of resources. You can create multiple resources. In this case, we create one job. You can create many jobs. You can create a job and a DLT. You can create a job and a dashboard. And then you have a bunch of environments. And environments is essentially like a collection of like where do you develop and where do you deploy to. So you can say during development, I have certain settings. I deploy to this workspace. During QA, I override some of the settings. I use a QA workspace. During production, maybe I want to have a schedule on my job. And I can kind of override this per environment. And what's nice is like all of the keys that you see, these are kind of the same values that you see in the Databricks REST API. So all of this is basically something that you can easily look up, and you actually have code completion and the ID for those two. But just want to give you like an idea how you would use a bundle. So I'm Alice. Think I'm Alice. And I'm writing my code. Hi, Justin. And I'm basically using my IDE, or use a CLI, or use the workspace UI to edit my code. And then when I'm done, I say like, Databricks bundle deploy, development, create all of the resources like in the namespace that's like scoped to me. So Justin can do the same thing. It's scoped to his name. There's no conflicts. When I'm done, I commit to Git into a branch. Justin can review my code, thinks it's good, but he also wants to see that actually the tests are passing and that kind of the test deployment is working. And that's where like a CI/CD system like GitHub Workflow would kick in. And then for the pull request, they would basically check out the code, do like a bundle deploy to the QA environment, and then do the test that they want to do. And once everything's nice, I can merge this into my main branch or a release branch. I can either automatically deploy this to a production workspace or kind of like a manual workflow trigger to deploy to production. But what this gives me is like I can very quickly iterate in development with isolation. I'm not stepping anyone's toes. And like the process to deploy to production is fully automated. And yeah, I want to show that too. Let's make this a bit. So what I did actually was I took this job and created a bundle. And you will notice like this is what we had on the slide. Like we have the name, we have a workspace, we have a job. And this job is now referring to the Python file that I just had open. There's like a local reference, but the tool knows any files that are locally will upload it to Databricks, and then we'll like patch the references to point to this file. And they have an override for production. For example, during development, I don't want to have the job to be scheduled. I think that would be a waste of time. But when I put it in production, I actually do want to put a schedule on it. Let's see. Okay, we get into the terminal. And what you can do is like use the new Databricks CLI, something we also just released as a preview. This is like replacing the old Databricks CLI that you might have used. And this has a bundle command. And I can just do Databricks bundle deploy. Development is my default environment, so I don't have to do anything else. And this will deploy my bundle to my Databricks workspace. And if I go to my workspace, oh, nice, need to sign in. What you will see is in the workflows, I get my development, fabian@databricks.com COVID job. And what I can also do is I can also run this job from here. So what I can do is Databricks bundle run, and then give it the job name that I have here. And what this is now doing is it will basically look up the job that it created and create a job run of that job. And the reason this is important is this is something that you can run as part of your testing pipeline. Like as part of your testing pipeline, you can do this deployment. And then you can run the job, and you will actually get a result back, like did this job finished successfully, yes or no? And if it doesn't, you can say, okay, I don't approve this pull request, we need to check that. Okay, I'm not going to wait for the output here, because the cluster is not running. So, wait, where's my, sorry. Here we go. So to wrap up, well, basically what we've done is we allow you to edit your code in the IDE, debug your code locally in the IDE, and then also provide tools to manage the development lifecycle from development locally, creating test environments, deploying these environments automatically, and also deploying production. Thanks.
All right. Okay. Thank you, sir. That was cool. All right.
No.
Yeah. Alice, right? Yeah, thanks. All right. Workflows. Like I said, we're jumping around. We got a lot of different topics. It's fun. So external orchestrations, like we see it a ton. And they've been, from what we've seen, they've been posing challenges. They can be hard to use, difficult to understand and root cause. I mean, a lot of them are just basically just doing cron jobs, and you're trying to say, run this, then that. But they're not necessarily aware of what's happening inside of the actual code, and and basically, could there be a better way of stitching these things together? And it's also just yet another service to potentially maintain. And I like to say they're not necessarily Lakehouse aware. So on the flip side, on the Databricks workflows, what this enables customers is to have super, super simple authoring for all sorts of data practitioners, actionable insights from the real-time monitoring. For example, when something is failing or failed, you'll see it right up top, super easy to see. You can see the lineage of where it was in the graph. There's even this super awesome like repair mode, because someone like me, I always type things wrong. Like maybe I fat-fingered my param or variable, and you'll see that come up, and I can go back into the job, fix the typing or fix the spelling, and then just hit repair, and it'll rerun and pick up right where it left off. So there's just super simple things along the way that are helping out. And then also, I mean, after running this for many years for customers, 99.95% uptime, which is pretty cool. And it's serverless. You don't have to manage it. But also, it is Lakehouse aware. So you can do tasks in the Databricks workflows, anything from ML training to inference, Databricks SQL. And like what that means is you can have say you're doing your medallion architecture, you can have a dashboard that comes, so after you do your bronze, silver, gold, you can have a dashboard that refreshes. You can fire off alerts. You can include all of these things within a single workflow. So to me, it's Lakehouse aware. We built this orchestration service to basically handle all the questions and all of the assets throughout the Lakehouse. All right, on the third section, which is fresh data and a fast time to value. This is where, I'm a runtime guy. This stuff is super, super awesome. Predictive I/O. So predictive I/O uses AI to determine when to prefetch on the read side, and then when to apply deletion vectors. This is more on like the update side, to ultimately allowing selective reads and updates to be dramatically faster without the need to create and maintain indexes. What does that mean? Great question. So predictive I/O for reads, effectively under the hood, using AI to eliminate the manual tuning for performance. I can't tell you how many customers I've seen over the years, hundreds, way over partitioned. I had this one customer, they did date, so year, month, day, hour, and then they had, within every hour, they had a 15-minute block. So I don't know, that's like a lot of different partitions in a given day. And when you look into the actual partition, there's 10 megabytes of data. Holy crap. So you can imagine Hive was, HMS was super happy with 5 years worth of that. And meanwhile, it's just unnecessary. No analyst in their right mind or no anybody is querying to that level of granularity. It's just silly. So that's one way people are trying to scratch that itch of how do I get really, really fast point lookups. The other classical way, I mean, this is nothing new, these things called indexes or indices for the purists, semantic purists, I guess you could say. So create an index. But now you go through this never-ending, like, hellish loop of, well, what column do I create an index on? How often do I have to update this index? It just starts to get kind of weird. And it's another opt-in knob. So that's one way. And now the final way is, well, how about an optimization service, which is doing pretty much similar things for you. It's just automated. Now, we thought, like, we can attack this problem different. And I know Reynold talked about it in the keynote this morning. And it turns out we can approach it differently. In fact, do nothing, and we're within 1 to 3 percentage points of a fancy index or an optimization service, except you have to do nothing for it. Because there's just some magic under the hood. And ultimately, what we're able to do is leverage the years of experience of building these complex systems to help these point lookups be super, super fast. So that's something that we're super, super proud of, that it's super, super fast. All right, and now predictive I/O for updates. This one I'm extremely proud about because merges used to take forever. I mean, yes, we created Delta Lake because doing updates on the lake sucked. And then Delta Lake was a much better way of doing updates or merges, upserts on the lake. However, we would still, like, if you had 1,000 rows in a single file, you would, and you only had to update a single one, you'd effectively be copying 999 rows when you're writing out this new file. But the first step in this journey was low shuffle merge that we did a couple of years ago. And now the final stop on this journey was deletion vectors. And so this effectively does like there's an algorithm that chooses, when does it make sense? It's like a cost optimizer to figure out when does it make sense to go with a deletion vector versus basically write all the rows out and effectively copy the information. But the TLDR is that it makes your merge 2 to 6x faster, or your delete 2 to 10x faster in real workloads. And now, I hate knobs. I hate adding additional comps and crap to the system. But since it's not fully GA yet, there is an alter table command that you have to run. But again, in the very, very near future, we're going to rip that away. It'll be default. But to me, this just makes performance in the Lakehouse scream and be awesome. So highly suggest you guys use this. In aggregate, with Delta Lake usage, about 60 to 70% of it comes from merges. So just imagine, and that's across the entire fleet of Databricks customers. So if I can say we can speed you up 2 to 6x faster for about 60 to 70% of all the usage of Delta, that'd be huge. So take advantage of this, or just wait a bit and it'll take advantage for you. Some kind of new things that we've done on the Spark side too. So Python UDTFs, so returning a table in the function, that was awesome. We recently, I don't know if it made it in 3.5. If not, it's super, super close. Hyperlog sketch-based procs distinct counts. Awesome, fun stuff. Named function arguments for people who want to maybe put their arguments in a different order within a function. People have been complaining about that for years, so we finally did that. That's a nice little hygiene feature. And then identifier clause. And then it wouldn't be a talk without an LLM reference. So yes, the Apache Spark plus LangChain LLM integration. All right, so we talked about if we did these 3 kind of main topics faster, ultimately it would help us ship data products faster. But don't take my word for it. Here's a couple of different customer slides leveraging all these and more things that we have going on. I like to focus on, at the end of the day, I mean, I told you, let's ship things faster. That's what people care about. Let's make people's lives easier. So you look, somebody like 7-Eleven, a 35% increase in their developer productivity. That's awesome. They saved a bunch of money too. That's cool. I don't mind that. And Walmart, similar, 30% increase in developer productivity, 10x faster, time to insights. So, I mean, these are just really, really cool stories. And just know, we are not stopping anywhere. In fact, I'll throw this out there. So I'm working on how to make upgrades not a thing anymore? Because I know you guys love doing upgrades. DBR upgrades are super easy. I don't pull my hair out. I don't complain. Well, just know we hear you. We're taking that up, so we're going to try to make your guys' lives easier. So hopefully at the next Data and I Summit, we're talking about that. So again, in closing, do 3 things. Ship data products faster. We talked about a lot of things here from the sampler platter, so we included, here's all a list of talks that might make sense. Now, some of them might have already happened, some might be in the future, but again, since it's a sampler platter, maybe you want to order the entree next time. Well, now you can.
Justin, I have to make a shameless plug.
Yes.
There's going to be an awesome talk tomorrow, 11:30. It's about development best practices and cows. Make sure to check that out.
Cows?
Cows.
Cows.
Yeah.
Cool. Thanks, Alice. All right, learn more at Summit. I was told to put the slide up. I have no idea what it does, but I did it. There you go. Again, Justin, thank you very much. If you want to talk run times, if you want to talk developer things, we're here hanging out. Thank you, guys.